Now what if the central limit theorem does not apply? Yeah, there are a couple of cases. Maybe our sample is smaller than 30, for example. It's a small sample, astronomically extremely common to have smaller samples than 30. Maybe the population is very, very unsymmetric. Maybe it's a power law. Yeah, then 30 is way too small. Or the statistic that we are testing is not obeying the central limit theorem. For example, the median of a distribution does not obey the central limit theorem. Then one way of doing this is by bootstrapping. It's an alternative approach to construct the confidence interval. And what we're doing is, since we have no way to estimate the population parameters, central limit theorem is not working, we don't know nothing about the population, and we know our sample does not obey the central limit theorem, so we have no idea what the population parameter is. The only thing that we have is our sample data. And I give you a start with an example. Let's say you have radio measurement or measurements of radio fluxes, 20 flux densities observed at some galaxies. 20 galaxies, I invented the numbers, so don't bother. 20 numbers. And the median is 8.87, let's say Jansky. Okay? Now bootstrapping works the following. We take from our data a random sample and we take it with replacement such that we have random samples of size 20, the same size that our data is. Yeah? So we take our 20 flux numbers and randomly pick 20 of those with replacement to create a sample from our sample. Then on this new sample we compute the statistics that we are looking for. I don't know, mean, median, some number that we are interested in. And then we repeat this many times to get a large number of bootstrap samples from our data, which at the end gives us a distribution of these bootstrap statistics. That's what I did here. These were this is our data. And here I create a function, bootstrap, that takes my data points and picks randomly picks as many as we got from this sample. And random choice makes it with replacement. So that means the same flux can occur twice or 3 times or 4 times. Yeah? And this I'm doing 500 times, and then I'm computing the mean value of these 500 bootstrap samples. And here is the distribution. This is what I compute the median. And here, this is the distribution of medians. Yeah, so since I combine from discrete fluxes, that means certain values cannot occur with a sample size of 20. I cannot get 11.2 as a number. It's not possible. Yeah? That's my bootstrap sample, and this is a distribution. And now the assumption is the distribution of this bootstrap sample follows the distribution of the population. And from this distribution, we now can compute confidence interval, error margins. Yeah? I can give now the median value is 8.8 plus minus this number, which I couldn't do before. Yeah. Okay. This bootstrapping is extremely handy and very common. Yeah, you will see this a lot. It's called bootstrapping because bootstrap is basically, I think if you're sitting on a horse on a saddle, you can pull on a leather strap to lift you up a little bit. The German word would be an den Haaren aus dem Sumpf rausziehen. Would be the equivalent saying, because we are with no access to the population other than the sample, we are kind of computing a statistics on the population. Yeah, so it's like magic. The problem is here that we need a representative sample. And if our initial sample is not representative, because we just were looking at interesting places on the sky, then of course we have the same bias in our bootstrap statistics. The problem is to decide how many bootstrap samples you need. And one good criterion is that you need, if n is the size of your sample, n times ln n squared as your bootstrap size. So that means, in our case, n was 20, ln n is, what is it? 1, 2, 1 point something squared, let's say 2. So, n is 10, n is 53.
Is 2.30.
ln, it's not log, it's the natural logarithm. So that's okay. So yeah, so that means for our size of 20, we would need a few hundred bootstrap things. If you have a sample of 1,000, you need 50,000 bootstraps.
Okay.